Just about 20 minutes ago here in Los Angeles, we felt an earthquake. According to the USGS, preliminary information is that this was a 5.1 quake. The epicenter was just north of Los Angeles County in Ojai.
Picture yourself standing at the edge of a bubbling, steaming geological wonder where the earth shifts and shakes beneath your feet. That's exactly what has been happening in Yellowstone recently. The recent increase in seismic activity is unlike anything recorded in decades. It serves as a stark reminder of the raw power and unpredictability of nature. So what's behind this surge in earthquakes? Could it be a sign of something worse to come? Let's explore how a Yellowstone official recently issued a serious warning after hundreds of quakes struck the park. Yellowstone, where nature's beauty meets history. Yellowstone National Park proudly spans the northwest corner of Wyoming and stretches into Montana and Idaho. This massive park is well known for two things: its incredible wildlife and its extraordinary geothermal features. Among these wonders, the Old Faithful geyser stands out as a crowd favorite, drawing visitors with its regular and forceful eruptions. While Yellowstone contains several ecosystems, the subalpine forest covers much of the park's area. The park's diverse habitats and unique geological features attract adventurers, nature lovers, and scientists alike, making it a treasured natural landmark. Long before Yellowstone became a national park, many Native American tribes lived there. The Crow, Shoshone, and Blackfeet tribes were among those who not only inhabited these lands, but also considered them sacred. Although much of their history is clouded in myths, stories, and the region's complex past, their presence gives insight into the rich heritage Yellowstone holds. Some believe that the spirits of these tribes still roam Yellowstone's wilderness. In the 18th century, this vast land was mostly unknown to European settlers, except for a few Native Americans and explorers. Records show Europeans first entered the area in the late 1700s. The Lewis and Clark expedition from 1804 to 1806 greatly mapped this region, while Meriwether Lewis led his group north to explore the Marias River. William Clark, who was the map maker and self-taught doctor, guided his team southeast toward Yellowstone. Although they didn't directly enter Yellowstone, their journey laid the foundation for future expeditions. In 1869, a group of non-Native Americans led by David E. Folsom made the first recorded trip into what is now Yellowstone. This small expedition sparked a wave of exploration that reached from the Pacific to Europe. Later trips, such as the famous Washburn-Langford-Doane expedition of 1870, followed. The most important was the Hayden Geological Survey in 1871, led by geologist Ferdinand Hayden and funded by the government. This survey carefully studied Yellowstone to document its stunning beauty. During this expedition, Hayden and his team, including artists, scientists, and photographers, spent months mapping and studying the area. Their detailed notes became the foundation for later scientific work and exploration. The artwork they produced provided some of the first visual records of Yellowstone's landscape. Finally, in March 1872, based on these findings, Yellowstone was named the world's first national park. Stories of shakes and shifts. Every year, Yellowstone experiences thousands of small earthquakes, most too small for people to feel. In history, 6 major quakes of magnitude 6 or higher have occurred. One of the most notable was the 7.2 magnitude earthquake near Hebgen Lake in 1959, just outside the park's northwest edge. This strong quake damaged the Hebgen Dam and caused flooding that changed the course of the Madison River permanently. The epicenter was just outside the park's western border. Suddenly, the ground moved like ocean waves during a storm, causing widespread chaos. This disaster created Earthquake Lake, formed where the Madison River Dam was destroyed. Geysers that had been inactive for a long time started erupting again in a steady rhythm. Roads were covered in debris, bridges collapsed, and buildings fell apart. Still, communities came together and rebuilt what was lost. Sadly, 28 people died in this event. Afterward, experts carefully studied the area's risks, leading to improved safety rules, stronger buildings, and better emergency plans. This earthquake sparked much discussion among scientists. They believe the stress it put on the area's fault lines could explain why earthquakes still happen in that part of Yellowstone. But not all quakes cause major damage. For example, the 6.1 magnitude quake in 1975 shook the park, but only caused minor harm. There is also a phenomenon called an earthquake swarm. Imagine thousands of small quakes buzzing like bees. For 3 months in 1985, scientists linked this activity to the Yellowstone caldera, the huge volcanic crater under the park. Then, in 2007, the ground under the caldera started moving again, with 16 small quakes in just a few days. These swarms seem like nature's way of stretching or adjusting itself. In December 2008, things got even more active. Over 250 quakes shook Yellowstone Lake in just 4 days, with the largest reaching magnitude 3.6. Then in January 2010, another 250 quakes rattled the area over 2 days. It's as if the earth beneath Yellowstone never truly rests. The mystery of supervolcanoes. The Yellowstone caldera is the largest volcano in North America and ranks second worldwide, only after the Lake Toba caldera in Sumatra. It's called a supervolcano because it formed from massive explosive eruptions. Beneath Yellowstone lies a huge chamber filled with hot molten rock. This underground lava lake stretches about 37 miles long, 18 miles wide, and reaches depths between 3 and 7 miles. The caldera we see today was created by an enormous eruption around 640,000 years ago. That blast released over 240 cubic miles of ash, rock, and volcanic debris. To put it in perspective, this eruption was more than 1,000 times larger than the 1980 Mount St. Helens eruption. It formed a caldera nearly 1 kilometer deep and about 45 by 28 miles wide. This event also left behind a rock layer known as the Lava Creek Tuff. The largest known eruption took place 2.1 million years ago. It expelled an incredible 588 cubic miles of volcanic material, creating the Huckleberry Ridge Tuff and the Island Park caldera. Then, about 1.3 million years ago, there was a smaller eruption that released 67 cubic miles of material, forming the Henry's Fork caldera and the Mesa Falls Tuff. Each of these massive eruptions covered large parts of North America with ash, disrupting the climate and causing challenges for many species. Today, scientists monitor Yellowstone closely because the area has experienced a lot of earthquakes lately. Hundreds of tremors have shaken the region, raising concerns about a possible future eruption. Between June and September 2017, there were numerous quakes, with some reaching a magnitude of 4.4. The main question is where this volcanic activity comes from. Some researchers believe it's caused by processes in the Earth's crust and upper mantle. Others think it originates deeper in the mantle. This is still uncertain because the Yellowstone hotspot appeared relatively suddenly in geological history. Another interesting detail is that the Columbia basalt lava flows appeared at around the same time and in the same region as the Yellowstone hotspot. Some scientists suspect these two are linked. As the hotspot moved, the Columbia lava flows followed and then calmed down. In 2018, a new theory challenged existing ideas about volcanoes. Instead of eruptions coming from deep, hot magma, some scientists suggested that water-rich materials rising from the base of the Earth's mantle could be the source. These watery components might come from pieces of an old tectonic plate called the Farallon Plate, which is sinking beneath the Cascadia region. Others disagreed with the popular idea that a large mantle plume, a hot column rising from deep within Earth, is responsible for Yellowstone's eruptions. They argued that the sinking Farallon Plate could block much of the plume's heat, acting like a barrier. So even if some heat gets through, it might not be enough to trigger huge eruptions. Studying Yellowstone's volcanic history helps scientists estimate when the next big eruption could happen. But even with advanced equipment like earthquake sensors and satellite imaging, predicting such events remains very difficult. Yellowstone's geothermal features add more complexity. While the bubbling mud pots and hot springs are fascinating, they also cause problems. These mud pots can spray mud onto solar panels, cameras, and scientific instruments, making maintenance tough. The park also releases natural gases like hydrogen sulfide, which smell bad and corrode metal tools. This creates challenges for researchers who rely on their equipment to collect data. Weather adds its own difficulties. Heavy snow in winter can cover and crush delicate instruments and block solar panels. Batteries can freeze, leaving equipment without power. In summer, lightning strikes sometimes knock out radio towers, disrupting vital communication. Setting up and maintaining scientific equipment in Yellowstone requires a lot of effort. Researchers often hike long distances over rough terrain while carrying heavy gear to reach remote spots. This hard work is necessary to install and care for monitoring devices at key locations for research and safety. The time and energy spent show how committed scientists are to studying this unique area. Nature's colorful display. Every 90 to 120 minutes, the Yellowstone caldera releases bursts of hot water and steam that shoot high into the sky. This regular eruption pattern attracts many visitors. But there's more. Inside the caldera, numerous hot springs, boiling pools, and mud flows exist. These features get their heat from the magma chamber located just a few miles beneath the surface. As water travels through cracks in the rock, it heats to over 200 degrees Fahrenheit before erupting, producing beautiful colors and textures. Among these natural wonders, the Grand Prismatic Spring is especially notable. It is the largest hot spring in the U.S. and ranks third largest worldwide. At its center, water bubbles at extremely high temperatures. As the water spreads outward, it cools down. In spring, vibrant colors appear thanks to tiny living organisms called microbial mats. These mats grow near mineral-rich edges and create a range of colors from green to bright red. The exact colors depend on the balance of pigments like chlorophyll and carotenoids, as well as the temperature of the water. In summer, the mats turn warm shades of orange and red, while in winter they shift to darker green tones. The middle part of the pool remains colorless and is heated to very high temperatures. The deep blue color seen at the center comes from the natural color of water itself. This blue appears strongest right in the middle of the spring, where its depth and purity create this striking effect. Visitors walking on the boardwalk see amazing patterns that look like giant flames, unaware they are standing on layers of heat-loving microbes called thermophiles. These tiny organisms, descendants of some of Earth's earliest life, thrive in the harsh environment of the Grand Prismatic Spring. When news about a recent swarm of earthquakes at Yellowstone spread online, social media filled with conversations ranging from guesses to serious worries and even doomsday predictions. People's thoughts mixed anxiety with fascination about Yellowstone's massive power. Some reacted with dark jokes, while others connected the earthquakes to global climate problems. Many feared that even if a volcanic eruption only affected a small area, ash clouds from sulfur emissions would impact everyone. In the middle of all this panic, the U.S. Geological Survey and Yellowstone Observatory stepped up to offer facts and calm. They assured the public that while the earthquakes were concerning, they didn't necessarily signal an eruption was near. Their statements were based on scientific data and expert studies, providing a much-needed calm voice. Still, the threat of a major eruption remained a possibility worldwide. A big worry was eruptions in the park's lakes, events which have caused global effects before. Yellowstone Lake is the largest lake in North America and the second largest worldwide. Sitting at a high elevation, it supports many forms of life and is fed by multiple streams and rivers. including the Yellowstone River, which flows into it from the southeast and out through the north. The lake is about 140 feet deep on average and reaches depths between 390 and 410 feet. Beyond its size, Yellowstone Lake has unique features. It splits into two arms, the southern and southeastern, which look like fjords extending from the main oval lake. On the west side lies West Thumb, a small formation created by a minor eruption of the caldera around 150 years ago. The hydrothermal features at West Thumb Geyser Basin, Yellowstone's oldest, were first reported in 1827 by a newspaper in Philadelphia. Yellowstone Lake is full of wildlife, including Canada geese, various ducks, American white pelicans, and the rare trumpeter swan. Watching Yellowstone's earthquake activity closely helps us understand volcanic risks. Different kinds of earthquakes can hint that an eruption might happen, but real warnings come from continuous monitoring of Yellowstone's volcanic and seismic behavior. Multiple organizations like government agencies, research centers, and park officials work together to evaluate these risks. The Yellowstone Observatory and the U.S. Geological Survey lead efforts to alert the public about possible dangers by tracking all seismic activity in the region. The University of Utah operates seismograph stations that act like detectives for Yellowstone's volcano. They have placed special devices called seismometers throughout the area to catch any earth movements that could mean the volcano is waking up. The scientists have a detailed plan divided into two main focuses: monitoring ground shifts with nuclear snooping and watching hot springs and geysers through hydrothermal monitoring. Nuclear snooping uses high-tech tools like GPS receivers to detect even tiny ground movements. By tracking these subtle changes, scientists can tell if volcanic activity is increasing. Hydrothermal monitoring involves observing Yellowstone's steaming hot springs and geysers, which provide clues about underground activity. Changes in temperature, chemistry, and gas emissions from these features help scientists know if the volcano is becoming restless. But the work doesn't end there. Researchers keep developing new methods to improve their volcano observation. They are considering ideas like drones with heat cameras or artificial intelligence to analyze volcano signals instantly. The future holds many possibilities. Of course, the scientists face tough challenges, such as navigating difficult terrain and maintaining all their equipment. Predicting exactly when a volcano will erupt is still uncertain despite their advanced tools. But these experts remain dedicated because the safety of Yellowstone and its visitors depends on their work. They spend their careers monitoring the Earth, acting as protectors in uncertain times. Their dedication was clear after the Maple Creek event on June 12, 2017. On a sunny day, a sudden shaking disturbed the calm town. What started as a mild tremor quickly grew stronger, shaking trees violently. Like scenes from a thriller, residents were shocked and understood something was wrong. Investigations showed increased seismic activity beneath the town, leading to urgent safety measures. At the same time, scientists focused on Yellowstone Lake, closely tracking earthquakes there. Reviewing data from 1983 to 2008 revealed interesting results. Out of 250 recorded earthquakes, the strongest measured 3.9 on the Richter scale and came from the lake area. Yellowstone's lake region is an important place for watching earthquakes across the park. Scientists don't fully understand why the lake's seismic activity is unusual, but their main worry is a possible eruption. Because of this, they focus on safety measures to reduce risks and protect people. A spokesperson from the U.S. Geological Survey told the public that an eruption is unlikely right now based on the current earthquake activity in the park. Still, it's important to remember that predicting geological events with complete certainty is not possible. Even with these reassurances, nature can change unexpectedly. The job of the U.S. Geological Survey and the Yellowstone Observatory is to detect those changes early and warn people. This way, they can stay safe without causing unnecessary panic. By being proactive and spreading information, these groups help prevent injuries and reduce risks from natural hazards. Imagine if Yellowstone's supervolcano erupted today. Deep underground, heat would melt rock beneath the surface. This molten material would gather, building pressure. The ground above would bulge and crack. When the pressure breaks through, gases trapped in the magma would explode, sending lava across the park. The eruption wouldn't just cause lava flows, it could kill up to 90,000 people immediately and cover areas up to 1,000 miles away with 10 feet of ash. Rescue efforts would be difficult because ash would block roads and stop most air travel, like what happened during Iceland's volcanic eruptions. The aftermath could be worse. Experts warn of a possible nuclear winter effect. Sulfur gases released into the air would mix with water vapor, creating a haze that blocks sunlight and cools the climate. This temperature drop could hurt crops and disrupt food supplies, similar to the effects of an eruption in Java in 535 CE. The chances of Yellowstone erupting in any given year are low, about 0.014%. Scientists keep a close watch. The magma chamber under Yellowstone's caldera is only partly molten, which may limit how big future eruptions could be. What about other supervolcanoes? They also keep scientists alert. Take the Long Valley caldera in California. Its volcanic activity started millions of years ago, with magma gathering deep underground. The Long Valley area saw eruptions between 3.1 and 2.5 million years ago, producing different types of volcanic rocks. Most volcanoes there, except Glass Mountain, were destroyed by a huge eruption about 760,000 years ago. That eruption threw material as far as Nebraska and Kansas. It left a large caldera, a bowl-shaped depression 2 to 3 kilometers deep. Some of the erupted material fell back and filled the caldera about 2/3 full. Today, the caldera is about 20 miles long and surrounded by mountains, except on the southeast side. A dome pushed up by magma sits in the middle, while the southeast slope is filled with solidified ash called Bishop. The caldera's rim is made of rock rising about 3,000 feet above the floor. Mammoth Mountain, made of lava domes, sits west of the rim and reaches 11,000 feet high. Along the western edge, there's a 25-mile chain of volcanic craters called the Mono Inyo craters. These craters have had eruptions as recent as 40,000 years ago. Scientists don't fully understand what drives the volcanic activity in the Long Valley area. Unlike Yellowstone or Hawaii, its activity isn't linked to a hot spot or tectonic plate subduction. Instead, it has a long volcanic history with magma beneath the surface. Yellowstone is also home to nearly 60 kinds of large mammals. It's like a busy city for wildlife. Animals such as the Rocky Mountain wolf, coyote, and Canadian lynx roam the area. The bison herd in Yellowstone is the largest in the country. Once, millions of bison roamed North America, but now Yellowstone is one of the few places with big numbers. From just a few bison in the early 1900s, their population has grown to over 4,000 by 2003. This shows the park's commitment to conservation. Recent studies have found a connection between the bison's behavior and what's happening beneath Yellowstone Lake. Before earthquakes start, bison act differently. They become restless and move away from places with more ground activity. This behavior might be nature's way of warning us about volcanic activity. The animals seem to sense changes before humans do. By watching the bison, scientists can learn more about what's happening underground. Understanding the link between animal behavior and volcanic activity helps us protect both wildlife and people. Volcanic eruptions can disrupt ecosystems and change how animals find food. Paying attention to nature's signs may help us prepare better. By combining scientific knowledge with observations from nature, we can develop better ways to keep people safe from volcanic risks. Yellowstone reminds us how fragile life on Earth is. Though it may seem overwhelming, there are people working to keep us safe even when things are uncertain. What do you think about the chances of a volcanic eruption at Yellowstone? Share your thoughts in the comments below.